Today in these lectures we will discuss about the Earth. You know that Earth is the third planet in the solar system, and which is the, as far as we know, which is the only planet in which life exists. In this chapter we will discuss about the different characteristics like the shape of the Earth, the different terms which are used in astronomy in reference to Earth, and also the different zones on Earth depending upon the temperature, and also we will discuss about the size of Earth, which is actually the radius of Earth. And we know that Earth is moving. It is having two types of motions, especially the rotation and revolution. So we will discuss about this rotation of Earth and the revolution of Earth. So while discussing it, we will mention about the Kepler's laws of planetary motions. Then the different motions, the rotation and revolution, with respect to these positions of the sun and moon, we can determine the time on Earth, namely the day, month and year. So we will discuss about the different types of days, different months and different year with respect to the motion of Earth. So these things will be discussed here, and also finally we will discuss about the seasons on Earth, how the different seasons are possible on Earth. So these things which we will discuss in this chapter, the Earth. So first thing is about the shape of the Earth. Now it is quite well known that the Earth is approximately of spherical in shape. If we are speaking exactly, it is almost ellipsoidal in shape, because at the equator it is little bit wider than the distance to the poles. So anyway, we can say that approximately Earth is spherical in shape. This thing, that is the shape of the Earth, we can demonstrate it in many ways. So here we will mention some of the justifications for considering the shape of Earth to be approximately in spherical in shape, and we will discuss all these things in qualitative way, not on the quantitative way. So the first thing is that Earth can be circumnavigated. That means when we start a navigation on the surface of Earth from a particular point, after traveling a distance, you can reach into the same point. That means you can circumnavigate the Earth. It was first done by, actually the circumnavigation was first done by Ferdinand Magellan. That you know that he is a Portuguese navigator who and his team first navigated the Earth, started from the Spain and passing across the Atlantic, Pacific and Indian Oceans, he returned to the same point. So that is the first proof for the thing that Earth is spherically in shape. Another very interesting thing which we can observe is that when we observe a ship which is incoming towards a shore or a port, then we can see that first its mast can be seen and then only its lower parts. Since the earth is spherical in shape, that is, if you consider a person is standing here and suppose earth is this one, then when a ship comes from here, its mast will be observed by this person standing here first, then only the lower parts. If the earth were flat, then he can definitely observe the entire thing, that is the lower parts as well as the mast of the ship at the same time. But in the case of an incoming ship, a person on the port can see the mast first and then only the lower parts of the ship. The similar is the case with an outgoing ship. When we observe an outgoing ship, the lower parts will disappear first and the mast will disappear finally. So this thing or this observation reveals that earth is approximately spherical in shape. Now another evidence for the fact that earth is approximately spherical in shape is the increase in the elevation of the pole stars when one travels towards the north, or when a person on the north traveling towards the equator side, he can see the decrease in the elevation of the pole star. Elevation means it is the angular distance of the pole star from the observer. When a person standing on the north, he can observe the pole star exactly above his head, that is at a 90-degree elevation. When a person is moving towards the equator and observing the pole star at a latitude of 45 degree, he can see the pole star at an elevation of 45 degrees. So this increase in the elevation of the pole star when one person travels towards northward is an evidence for the earth to be spherical in shape. Now another directly observable thing is that when we observe the earth's shadow on the moon by the sun at the time of lunar eclipse, we can observe it to be in circular. That is, if you consider sun is at this point, the earth is here, and suppose moon is here. Now during the lunar eclipse, the shadow of the earth on the moon is circular in shape. That means the shadow of earth is circular. For only the spherical objects we can have this spherical shadow. So this is another evidence, or it is the most promising evidence for the shape of the earth, and from that we can say that the earth is approximately spherical in shape. So these are the different reasons in which we can justify that using these reasons we can justify that earth is approximately spherical in shape. I'm repeating the things again. The first thing is that earth can be circumnavigated only for a curved object or curved path, or we can reach the same initial point, so that we can say that earth is spherical in shape. It is first circumnavigated by the Portuguese navigator Ferdinand Magellan in 1950 1591. It is actually done in 1519, and he returned on 1522. Another reason is that an incoming ship from any direction first shows its mast and then its lower parts. Similarly, an outgoing ship first the lower parts will appear and then the upper parts until the ship completely disappears. This is due to the fact that the earth is not flat. Another is that the increase of elevation of pole stars observed as one travels towards north is another proof that earth is not flat. For if the earth were flat, the pole stars would remain at the same elevation. And another justification is that the earth's shadow on the moon by the sun at the time of lunar eclipse is circular, and if the body is not spherical, its shadow cannot be circular. So these are the justifications for the approximate shape of earth. Now let's discuss about some of the terms which are used in astronomy in connection with the earth. Since we know that earth is rotating about its own axis, or earth has two types of motion. One is the rotation and another one is the revolution. You know that earth is rotating about its own axis from west to east, and earth is having a revolutionary motion around the sun in the counterclockwise sense. So any object rotates, then it will be about certain axis, and that axis is called Earth's axis. And if you consider Earth to be a spherical one, which is evident from the previous justifications, and suppose Earth is rotating from west to east, suppose in this direction, then the axis, suppose like this. I am drawing this axis little bit tilted because you know that axis of Earth is little bit tilted when we are considering the plane of orbit of this Earth. So it is little bit tilted, and this is the axis of Earth. The points on the surface of the earth where the axis of earth meets, that is these 2 points here, the axis of earth meets the surface of the earth, is called north pole and south pole. This is the north pole and this is the south pole. For reference, usually we will consider earth to be exactly spherical and write like this. The axis is exactly perpendicular to our paper, so that this is the south pole and this is the north pole. Now if we consider the great circle, actually great circle means it is a circle on the surface of a sphere whose plane passes through the center of the sphere. Suppose if you consider a sphere, suppose this is sphere and this is the center of the sphere, no doubt. Now if you consider the circle which is on the surface of the sphere, whose plane, the plane of the circle passing through the center of the sphere is called a great circle. So now if you consider a circle like this, which is exactly perpendicular to this axis, whose plane actually passes through the center. Now if you consider a circle like this, which is actually encircling the surface of the sphere, then this circle also passes through whose plane, the plane of this circle also passes through the center of this sphere. then these circles are called a great circle. And remember that we can draw infinite number of great circles on the surface of a sphere. Here, if you consider a great circle whose plane is perpendicular to the Earth's axis, which is called a terrestrial equator. The word terrestrial is actually used for the terms associated with the Earth. So it is terrestrial equator. So terrestrial equator is the great circle on the surface of the Earth whose plane passes through the center of the sphere, also whose plane is perpendicular to the axis of rotation of Earth. So now if we consider this great circle and this great circle which is called the terrestrial equator. Now if you consider the distance of any point on this equator from the south pole and north pole, you can see that they are equidistant. That means all the points on the terrestrial equator are equidistant or equal distances from the north and south poles. Now if you consider any other great circle, that is the great circles other than the terrestrial equator, for example this is Earth and this is a great circle, this is actually on the front side of the Earth and this is actually on the back side of Earth. Then suppose this is the axis of Earth, then this is the north pole and this is the south pole. Now if you consider this point, actually this point is not on same distance from the south and the north pole. It is near to the north pole and far away from the south pole. But if you consider the Earth and the equator means whose plane is perpendicular to the axis of Earth. Now any point on this circle will be equal distance from the north and south poles. So terrestrial equator can be defined in this way, that it is a great circle whose plane is perpendicular to Earth's axis. Or another thing we can say about terrestrial equator is that it is a circle which is equidistant from the poles passing east-west. Or we can say that equidistance from the north and south poles. Now another thing is that if you consider the Earth and the axis of Earth, here you can draw many great circles like this, where these sections of the Earth's surface, that is the circles on the Earth's surface whose plane actually passing through the Earth's axis of rotation, then that circle is called a terrestrial meridian. So the great circles on the surface of the Earth whose plane actually passing through the axis of Earth. In the previous case, the great circle whose plane is perpendicular to the Earth's axis, which is called a terrestrial equator. So we can have only one terrestrial equator, that is one great circle whose plane is perpendicular to the axis of Earth. But when we consider the terrestrial meridian, which is actually the circle whose plane passing through the axis of Earth, then we can have an infinite number of terrestrial meridians. So terrestrial meridian is the section of Earth's surface by a plane passing through the Earth's axis of rotation. Thus we can say that every place on the Earth's surface has its meridian. If you consider any point on the surface, suppose this is Earth and any point, this is a point, then we can have a circle or section like this. This section actually is passing through this point and whose plane is passing through the axis of Earth. Now if you consider this point is also having a section like this, whose plane is passing through the axis of Earth. Any point on the surface of the Earth will have its own meridian, and I told you, so we can have infinite number of meridians on the surface of Earth. So the meridian of Greenwich is taken to be the prime meridian from which the latitudes of all places on the earth are measured. Now if you consider the latitude of this Greenwich, it is actually which is called the prime meridian, the meridian which is passing through the airy transit instrument. Airy transit instrument. It is an instrument named Airy, the George Airy, an astronomer. Airy transit instrument in the Royal Observatory, Greenwich, London. So that is taken to be the prime meridian whose latitude and longitude, that we will discuss later what latitude and what longitude is, but whose location is actually represented by latitude and longitude is given by 51 degree 28 minute 40.1 seconds north is the latitude, and the longitude is 0 degree 0 minute 5.3 seconds west is the prime meridian. So the meridian, I told you that if we want to locate the position of anything on the surface of Earth, we have to consider this latitude and longitude. To discuss this latitude and longitude, we should have an idea about the terrestrial equator and the terrestrial meridian. For Earth, we can have only one great circle whose plane is perpendicular to the axis of Earth and which is called the terrestrial equator, but we can have a number of sections on the surface of Earth whose plane is actually passing through the axis of Earth, which is called terrestrial meridian. So we can have a large number of terrestrial meridians. So one of the terrestrial meridian has to be taken as the reference or the starting one, and which is taken to be the meridian which passes through the Airy transit instrument in the Royal Observatory, Greenwich, London, whose location is given by these points: 51 degree 28 minute 40.1 seconds north and 0 degree 0 minute 5.3 seconds west longitude. So which is called the prime meridian. So all the meridians of the point are measured with respect to this prime meridian. So now let's discuss about two important thing or important quantities which is used to locate the positions on the surface of Earth, which is the latitude and longitude. The latitude of a place is its distance north or south of an equator measured along the meridian of the place. For example, consider this to be Earth, and it is having the equator like this, and this is the north pole and this is the south pole, let's say. Then suppose I want to measure or locate the point at this point, then we have to consider the meridian of this place, which is the section of the surface of Earth whose plane passing through the axis of Earth. So this is the meridian through this point. So now the latitude of this point is this place is its distance north or south. Actually it is towards north, so distance north of the equator measured along the meridian of the place. Suppose the point is here, then it is the distance on the meridian from the equator towards south, so it will be south. So this distance is the latitude of this point. So if we consider this latitude of any point on the surface of Earth, so it will be a meridian, it will be a meridian, it will be a meridian. And if we consider any point on the surface of Earth, then if it is in the point is on the or the place is on the north pole, then this latitude will vary from either from 0 to 90 degree north. So this latitude is measured in degrees from 0 to 90 degree north. The minimum latitude is 0, which represents the equator, and 90 degree north represents the north pole. So any point on the north pole of the or northern hemisphere of the Earth will be having a latitude of 0 degrees to 90 degrees. Or if the point is on the south pole, then the latitude of that place will be either 0 degree or 90 degree south. So the latitude of a place varies from 0 degree to 90 degree north or south. Another interesting thing is that if you consider two meridians, suppose these are the two meridians, and if you consider 2 points, and these 2 points are on the same parallel on the meridian, that is, this is a meridian and this is another meridian. That means if you consider this as the equator, and this distance and this distance are same, then we can say that it is a same parallel to the equator, have the same latitude. So now we can say that all the points on this circle will have the same latitude. That means the locus of all points which forms a circle which is parallel to the equator, terrestrial equator, have the same latitude. Now if you consider the longitude, which is actually the arc of the equator between the prime meridian and the meridian of that place. To understand it, suppose this is our Earth and this is the axis, and suppose this is a meridian. Sorry for that bad drawing. This is a meridian. Suppose this is the prime meridian that is passing through the Greenwich. Then meridian of, suppose I want to find the location of this point. To locate it, we have to specify the latitude and longitude of that place. Latitude is the distance of this point along the meridian from the equator. So actually this angle will be the latitude. Measure this angle, that is, we can have a vector towards the, suppose this is Earth's surface and this is the equator and this is the point which we want to calculate. Suppose we are considering this is a meridian, then this angle, which is usually denoted by phi, is the latitude. That is, this angle actually represents the distance of this point north from the terrestrial equator. So so that we can specify some phi degree north or phi degree south as the latitude. Now to find the longitude of that place, it is the arc of the equator between the prime meridian and the meridian of that place. So suppose this is the prime meridian and I want to find the point at this point. Meridian of this point is this one. Then draw an arc. This arc is actually parallel to the equator, and measure the distance of this arc. Then that will represent the longitude. This arc, actually Earth is rotating, you know that. So we are actually representing the time taken by the Earth to reach this point to this point is called the longitude. So longitude of a place is the arc of the equator between the prime meridian and the meridian of that place. It is actually, so the meridian may be at this point. So for the prime meridian the longitude is 0 degree, and for a, if we consider the meridian, the longitude of these places, it is increasing and it actually reaches the 180 degree east or west. So if we are measuring in this way, we can have a 180 degree. It is actually a 360 degree circle. Suppose this is a prime meridian point, then this point will be at 180 degree. So either we can go in this way, that is towards west, and towards east, or we can go in this way to reach this point. This is west. So it will be, the longitude will vary from 0 degree to 180 degree east or west. Now if you consider the longitude of this point, it will be same as the longitude of this point. If you consider a point here, it will be having the same longitude of this point. So if you consider all the points on this meridian, they will have the same longitude. So we can say that all the places on the same meridian have the same longitude. So that's all about some of the important terms which we are commonly using while discussing astronomy in reference to Earth. The one is the terrestrial, The terrestrial refers to Earth, that is terrestrial equator. Then North Pole, the South Pole, then meridian, then latitude, then longitude, etc. So I hope that all of you understood all these terms. Now we can discuss about the different zones on Earth, that we can discuss in the next video.